Hi friends, myself Kunal and we are learning building models with machine learning. So in this lecture, we'll learn about unsupervised learning and a special form of unsupervised learning that is K-mean clustering. Okay. So far, what we have learned, what is machine learning? Learning about the world from data. So we have some info and noise in the past, and if we are able to predict with this info and noise that what will happen in future, then this is called machine learning. So let's summarize a bit about machine learning. So let's say we have info of rain that in July month, from 21st July to 25 July, it is raining in last 5 years. Okay. So now we need to predict that what will happen in 2023 in July from 21st to 25th. So as we have data, कि अगर 25 से 25 के बीच में लास्ट 5 years में रेन हुई थी एंड वेदर कंडीशंस लाइक उससे पहले बहुत समर्स थी, बहुत हीट वाला वेदर था, तो हो सकता है कि इस बार भी रेन हो. So this is prediction, but it has some noise also that the dates are not accurate. It may happen that the rain continue only for 2 days from in 5 days that we are analyzing. So the data is always having info plus noise. So like info is it rains in last 5 years in June, or there are 75% chances of getting a head. Okay, so if we have random cause of coins, then we have 75% chances of getting a head, and there are 30% chances of getting a tail. But if we want to predict what will happen in the next toss, then we cannot say with accuracy that, okay, it will be a head or a tail, but we can say that there are 75% chances that it will be a head and there are 30% chances that it will be a tail. Similarly, if we want to predict that the rain will begin on 25th of June or not, then we can say that there are 70% chances that the rain will happen on 25th June, and there are 30% chances that rain will not come on 25th of June, because the data that we are having, that on which we are building the machine learning models, is having both info plus noise. And हमारा टारगेट क्या होता है कि हम नॉइज को रिड्यूस करें और मैक्सिमम इंफॉर्मेशन का यूज करें मॉडल बिल्डिंग में. So this will lead to overfitting and underfitting of data. Like अगर हमारे पास बहुत ज्यादा नॉइज है और हम सारे प्रेडिक्शन उसी के अकॉर्डिंग कर रहे हैं, तो वी कैन से दैट वी आर ओवरफिटिंग द डेटा. हम सारी नॉइज लेके, लाइक अगर हमारे पास कोई ऐसा ईयर है जिसमें हर रोज रेन हुई है, so there is rain every day, then if we are trying to predict with that data कि हम रेन होगी या नहीं, so that is overfitting of data. या हम किसी ऐसे ईयर से कंपेयर कर रहे हैं जिसमें रेन हुई नहीं है, ओके, एंड वी आर ट्राइंग टू प्रिडिक्ट कि रेन होगी या नहीं होगी, so that is underfitting the data. So we gather the data in such a way that we have more information and less noise in our data, and if there is more noise in our data, then we'll try to reduce the noise. So this is an important point, that we can expect info will repeat in future, but noise can change. So जो information है हमारे पास accurate, which is helping us in building the data, which is the basic of machine learning, we always assume that that information will repeat itself in the future, but the noise can change. Okay. So if there is a way where we can capture only the information and make a model out of it, it is the best machine learning model. But we have both info and noise. That's why we get overfitting and underfitting model. Now, how to reduce the noise and focus more on information is what we learn in machine learning. Okay. So in my last lecture or in my previous lectures, we have learned about supervised learning. ओके, सुपरवाइज लर्निंग में हमारे पास क्या बेनिफिट होता है? So what is difference between supervised and unsupervised learning is, if we have a table, okay, where we have one column y and there are x1, x2, x3, okay, or we have a graph like this where we know what is y on the variation of different axes. We know what is a y column with respect to different x column, where different x values are predicting a y value, then this is a supervised learning model. What is it? Is supervised learning model. But when we don't know what is our y, like for a retail store, okay, and there are, let's say, 100 people enters in a retail store, which have different choices. So some are the family members, okay, some have families, so they go for milk, rice, or let's say vegetables. Then there are 25% people which are bachelor or at young ages, so they will go with the Maggie, let's say, plus cold drinks, plus packed food. Then let's say there are 50% party people come entering in the store. So what they will choose? They will choose snacks plus drinks, right? So here we don't know that how we need to group these items. So if we put a milk in this set of, in the rack of these items, then it will not help us, right? Because the people who wanted to purchase rice and vegetables, if we put milk near to them, there are more chances that they will purchase milk. Similarly, let's say if we put our drinks, or let's say hard drinks, in the vegetable section, okay, then there are 80% chances that these drinks will never get sold out, because the people who are looking for snacks, they wanted to have drinks, but the people who are looking for rice and vegetables, they don't want drink. So we don't know exactly what is our y value, but we just want to group these items based on what kind of people are purchasing them. Okay, so let's say that आपको एक और एग्जांपल देता हूँ अनसुपरवाइज लर्निंग का. So let's say इसी एग्जांपल को ब्रीफ में देखते हैं. So we have a store which has milk, drinks, okay, and rice, and let's say flour, okay, and then, but we can have packed food, and so that's how we get the data. These are our columns, and one column is the customer ID, okay, and we are listing here how many items they have purchased. Okay, let's say we have snacks also. So we can have data like, for one customer ID, they have purchased 2 quantity of packet food, okay, 2 quantity of drinks, and 1 quantity of snacks, and 0 quantity of milk, rice, and flour. For second customer ID, they have purchased, let's say 5 kg flour, 2 kg rice, and 1 kg milk. Okay. So we can have this set of data, and based on this, we want to uh, you know put all this data together in shelves. So we have 3-4 rows in the store, and basically we want to divide this data into groups. So let's say our store is having, this is the entry of store, and we are having 4 rows. Now we need to decide that what item we need to put in which row. Okay, that's not an easy task, right? So what the store owner will do, he will try to get data from different stores, that how he can place these items, all these items, into different racks of the store. And based on this data, he will divide these items into groups. Okay. Based on this, he will divide these items into groups. Sorry guys. Okay. So yeah. So now he will try to make groups of these, where we have snacks and drinks and packed food. And then there will be one more group which will be having milk and rice and flour. And then let's say if he has only these 2 items, then also he can divide these items in such a way that, okay, there are more often that people are buying rice and flour at the same time, and then they are buying snacks and packed food at the same time, and let's say there is one more section of drinks. So that's how the supervised learning, the unsupervised learning work, where we don't know that what is the y value, but still we need to, there is requirement to find groups within the data set that we are having. Okay. So unsupervised learning, there is not any specific label to what is output. So if there are multiple columns, we don't know what we need to predict. We are just trying to group the information in various groups, right? And then groups will tell what can be target variables. Like, so there's the same example that I have explained you earlier. Okay. And now these groups that we make here, these groups, these are called cluster. Okay. So with unsupervised learning, we are always trying to make clusters of the group. So grouping down the objects of similar type is called clustering. If something is close to each other, we call it similar, else not similar. Objective is to group similar data points into groups. Like there is one more application of unsupervised learning, that is automatically organize similar emails into folders. So we are basically simplifying data by clubbing many data points into some data groups, right? So if we have different data here, we are basically trying to group this data point together. And these are different clusters, and we can say that all the data that is belonging to same cluster are falling in one category. So this is category 1, this is category 2, and this is category 3, right? Okay. Now there are 2 ways in which we can club these elements. Okay. So one obvious way is that we find the nearest distance elements. Okay. So it is assumed that in a multi-dimensional plane, or let's say in a 2D plane, if 2 points are nearer to each other, then we can say that these points are similar. Okay, like these 2 points are nearer to each other. These 2 points are nearer to each other. Similarly, these 2 points are nearer to each other. Okay, so these can be called, these are clustered. But now there are problems arises, like if we have a data like this. Okay, let's see. And data like this, right? So in this case, from this coloring point, it is obvious that this is a similar kind of data. Okay, but let's consider this point. With respect to this point, this data is very far from this point, and this data is very nearer to this point. So there are techniques required in machine learning which can segregate between these two data. So that's why we need a different kind of machine learning techniques, different kind of unsupervised learning techniques, so we can differentiate between this kind of data. And similarly, there are other ways, like in this case also, like in this case also, uh, if we consider this point, this black point is near to it than this red point, right? So we need we need a way in machine learning so that we can club all this data, right? You are understanding? Are you getting my point? That from this graph, it may seem that it is very easy. What is the need of some machine learning model to group this data? It is obvious to group these data. We have red points, we have blue points, we have black points. But see, if we have this kind of data, it is very hard to group data directly, even by seeing the data. Okay, so there is no, we need a different model so that we can separate this kind of data. Now, in an unsupervised learning, obviously everything is dependent on distance, and so there are different type of machine learning models based on different type of distance calculation, and also the way distance is calculated. Okay, so okay, let's see. So let's say we have this column of this data with us. Okay, it has multiple rows and multiple columns. Okay. Now you are understanding this, all these columns are x values, or these columns are the points in space. So every column represent a axis and every row represent a point in space. Okay, so like for this data, it's a 5-dimensional, it's a is a point in 5-dimensional space, right? Now how to find distance between a and b point? We can use uh, so find, there are different type of methods in which a distance can be found, like Manhattan distances, Euclidean distances, and Chebyshev distance. These are the three distances that we generally follow. Okay, so there can be, let me give a visual that how can distance be different. Okay, so 1 second guys, I need to plug in my laptop. Okay. Yeah, So there are different ways to measure distance. Okay, let's say we have two points in space, A and B. So one distance is, let's say A is having coordinates x1, y1, and this point is having coordinate x2, y2. Then distance between these 2 points can be x2 minus x1 ka whole square plus y2 minus y1. Basically, the diagonal distance. Okay, this diagonal distance. But there can be other distance as well. This is called Euclidean distance, by the way. So if there are 3 points, then it will be x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 square, and under root of all of these. Okay, this is Euclidean distance. Now, another distance can between these 2 points is, let's say we cannot walk diagonally. We can only walk in straight line. Okay, so then distance will be x2 minus x1. Okay, we have reached this point, and then y2 minus y1, and we reach this point. So this can be another distance, and this is called Manhattan distance. This is called Euclidean distance. Okay. Now there can be another way of measuring the distance. Okay, that is the chessboard distance. Okay, we'll come to it. So number of squares in the distance. So let's say we are not counting the point. We are counting the square instead. Then that distance will be minimum of y2 minus y1 or x2 minus x1. The number of square present between these 2 points. Okay, like we move in chessboard. So that is Chebyshev distance. So there are 3 measures of distances between 2 points, and all are accurate. It just depends which distance we want to take. Generally, we are using in most of the learning algorithms that is called Euclidean distance. Okay. Now there's another distance formula which is called Minkowski distance. Okay, and it has a generalized algorithm, generalized this way. Sigma I to n, if there are n points, then I to n, and then distance between each point, power p, and 1 by p. So see, by having different values of p actually give us the different kind of distances that we just discussed. So if p is 2, then it's x1 minus xi minus yi square, and under root of it, then it's a Euclidean distance. Then for p equal to 1, it's Manhattan distance, and p equal to infinity, then this will be a 0. This will be a 0 term, and then it will be a Chebyshev distance. Okay. So now all these things that we discussed previously, the 3 kind of distances, these are the measure of similarities. Now let's go to the machine learning. Okay. So there are different type of clustering in machine learning, in unsupervised learning. One is connectivity based clustering, which we call hierarchical clustering. Okay, where we calculate distance between each 2 points, right? Like distance between A and B, A and C. So you are getting like for n points, we need n square distances to store, right? And then there is a centroid based clustering, that for the points, we define random centroids between these points. Okay, and then we try to group these points based on this centroid. So like in the diagram where we discuss, okay, so let's say we have three random centroids here. One is here, one is there, and one is here. So we try to find the distance from these centroids, right? And then we are able to find these clusters. Or there is another way that we need to find the distance between every pair of points. So distance between these 2 points, then distance of this point from this point, this point, this point, this point, this point, and then we trying to make a group, right? So there are multiple ways where we can define the measure of similarity and how we can make clusters. Okay. But in hierarchical clustering, we need to have a lot more computation. Like for n points, we need n square computation. But in centroid based clustering, we need to find distances only n into p times. That p are my data points. So we need to store only n into p distances with us, right? Okay. So this is some simple calculation. Let's say we have 1000 rows. For connectivity, we need 1000 C2 implies these many points we need to store. And for centroid base, we only need to store 5 into 1000. Let's say for 5 mean clustering, where we find 5 centroid points, and then we need only 5000 values that we need to store. So this is basically calculation difference or mathematical difference between these two kind of algorithm, but this doesn't qualify that this clustering is always beneficial over this kind of clustering. They both have their own advantages and disadvantages, and we'll discuss that in this further lecture. Okay. So in future lectures, we'll learn about these two techniques in detail. That's what is connectivity based clustering and what is centralized based clustering. We'll do some hands-on on both of these algorithms. Okay, guys. So please, अगर आपको ये channel पसंद आया, आपको information थोड़ी informative लगी है, तो please subscribe the channel and keep watching my future videos. In next videos, we'll do hands-on for both these kind of clustering. We use the Jupyter notebook and we use different data sets, and then I'll actually show you that how these different clusters look when we do the clustering. Okay. Thank you guys for watching. Have a great day.